So last lesson we learned one way to write linear equations in the form y equals mx plus b, the slope-intercept form. Today we're going to take a look at another way to write linear equations. And that is some number times x, and some number times y, and some number is equal to 0. And there's a bit of a condition on this, because these numbers a, b, and c must be integers, and an integer is a positive or negative whole number like these numbers. And also there's one other condition, is that the a value, the first value, needs to be positive. This might look a little bit complicated, but it's actually pretty easy to work with. A lot of what we'll be doing in this section will be converting between different forms. This general form is also known as standard form, and the slope-intercept form, y equals mx plus b form. So, and that just comes down to algebra and algebraic manipulation. So we'll get questions like this one. Convert y equals 2x plus 3 to general form, and you'll notice that this is in y equals mx plus b form, so it's in slope-intercept form. And to convert this, I just need it to look like some number times the x's. So just keep this value as your x's. So there's some number times your x's. And then I need my y's next. Well, right now the y's are on the left-hand side of the equation, and I kind of need them to move over with the x's. And the way that you do that is just some algebraic manipulation of subtracting y on both sides. So you then get 2x minus y, and then the plus 3 is equal to 0. It really doesn't matter if I move everything over to the left-hand side or everything over to the right-hand side. Once it's equal to 0, it's interchangeable the way that you write it. So again, it's just algebraic manipulation and practicing that. Let's take a look at another example of this. In this case, we're going to convert y equals negative 1/3 x plus 1/5. And the easiest way to do that is to not work with fractions. We did see in the very beginning that a, b, and c, the numbers that have to come in front, the coefficients that have to come in front of x and y, have to be integers, not fractions. And so the easiest thing to do if you have fractions is to multiply everything by a common denominator. Let me just fit that into the page a little bit better. There we go. So in this case, we're going to take everything and multiply it by 15. So here's my original equation, y equals negative 1/3 x plus 1/5, and I'm going to multiply each thing by 15. So that's going to multiply by 15, so is this one, and so is this last term. 15 times 1y is 15y's. 15 times negative 1 is negative 5 divided by 15 times negative 1 is negative 15 divided by 3 is negative 5x's, and 15 times 1 divided by 5 is plus 3. So don't think about it as fraction multiplication. Think about it as multiplying by the numerator and dividing by the denominator. In fact, it's even easier to divide by the denominator first. So 15 divided by 3 is 5 times negative 1 is negative 5. 15 divided by 5 times 1 gives you 3. It's much faster to think about it that way. So that's your first step. Then we need to get it into the form ax plus by plus c equals 0. So basically just make it equal to 0. In this case, it's easier to move this negative 5x to the other side. So I add 5x to both sides. I get 5x, and 15y was already there. Then I need to subtract 3 from both sides. So minus 3, and that's equal to 0. So on this side I added 5x and I took away 3. And there is your answer in general form. ax plus by plus c. It's okay if c is negative 3. Plus negative 3 is the same as minus 3 is equal to 0. Okay, to graph general form, it's a little different than graphing y equals mx plus b. With y equals mx plus b, you can just graph the y-intercept and then use the slope. To graph general form, it's a little bit trickier. You have two options. Option number one is what I like to do most of the time, which is to convert every equation that you get in general form to y equals some number times x plus b, and then use slope-intercept form to graph it. Another option is to use the intercepts. And using the intercept is actually a little bit faster if you understand how to do it with the intercepts. So let's do an example, and then we'll take a look at maybe one more example, and that's the end of the notes for today. Okay, so this example is to graph 5x plus 3y minus 15 is equal to 0. And we can graph this in both ways. We can make it into the form y equals mx plus b, and that's simply solving for this y value. And if you solve for that y value, that means get everything else to the other side. So subtract, so you'll have those three y's by themselves. Once you subtract away 5x from both sides, so you get minus 5x, and you add 15 to both sides, and you get plus 15. And then divide everything by 3. So divide the first term, and divide the x term, and divide that last term by 3, and then you get y equals, leave this as a fraction. Hopefully by now you understand why that's better as a fraction, and plus 5. This one worked out fairly nicely, so when we go and we graph this, we know that we have a y-intercept of positive 5, and we have a negative slope, so it goes down 5 and over 3, down 5 and over 3, and it looks something approximately like that. I guess that point was a little bit off. The alternate way of doing this is to find the intercepts, and I said this was a little bit faster. It's a little faster, but it is a little tiny bit trickier. So last day I mentioned that when you want to find intercepts, you can plug in for the x-intercept. It always has a y value of 0, and knowing that if I want to find the x-intercept of my graph 5x plus 3y minus 15 is equal to 0, if I make the y value a 0, then I get 5x minus 15 is 0, or 5x is equal to 15, or x is 3. That is my x-intercept. And notice, x is equal to 3. There's my x-intercept. If I want to find the y-intercept, I simply make x is equal to 0. And so I take my equation, the whole thing, 5x plus 3y minus 15 is equal to 0. I make the x 0, so 5 times 0 is 0, and I solve for y. And so if I add 15 to both sides and divide both sides by 3, I get y is equal to 5. And then I just connect the intercepts together. And you'll notice you make the exact same line. You're welcome to use either method. If you understand the x and y intercept method, it's actually faster because you just plug in 0 twice, solve for the other variable. You don't have to show all your work to do that. Just tell me what the x and y intercepts are and graph it. If you graph it using y equals mx plus b, you're just strengthening your algebra skills to make those conversions, and you're practicing y equals mx plus b, which is a massive skill for this unit and the next unit and off into Math 11 and Math 12. So for our last one, we're going to take a look at graphing y equals 5 and x is equal to negative 2. And these are both tricky ones because you can go and think about graphing this one as y equals mx plus b. It's y equals no x and then plus 5. Y and is, and there's your 5 on the other side. There's no x's over with that 5. That's why I put that no x. And this gives you a little hint that the slope is 0. And so when you go to graph this one, you get a graph that looks like a flat line because the slope is 0. So you do know the y-intercept, the y-intercept 2, 3, 4. The y-intercept is 5, and you get a flat line. So it turns out whenever you have y equals some constant, you get a flat line at that constant with that y-intercept. Something different happens with y equals -2. You can't make it equal to y equals mx plus b because there wouldn't be any y's. So since you can't convert it to y equals mx plus b, you cannot use y equals mx plus b to graph it. That means, well, it doesn't have a slope of 0 because we graphed one right now that had a slope of 0, and it doesn't have any other kind of slope that exists either, or else it would be of the form y equals mx plus b. You have seen lines that don't have a slope that can be defined, and those are lines that are undefined. And so anytime you get x is equal to some number, you have an undefined slope. And an undefined slope goes straight up and straight down. And the point that it goes through is when x is equal to -2 in this case. And so your line goes straight up and down this way. The way that I remember it is, if I can convert to y equals mx plus b, I know that I've got a 0 slope. If I can't convert to y equals mx plus b, I know I have an undefined slope, and it goes straight up and straight down. Okay, we'll see you in class so that we can practice some of this.